Good evening and welcome back to Math Monday, the weekly show I do where I try to make things just a little bit clearer when it comes to math education. Where we last left off, it's been a few weeks. I was making my way through third grade, and normally right now is about the time when I would start ranting about some off-topic thing before diving into Khan Academy. But I think this time I'm just going to jump right in because we've got a lot to cover, and I want to try to cover the rest of third grade in the next stream or two if I can. So that's why I'm talking so fast, and that's why we're moving on right now. Okay, so we are going to courses. We are currently 67% of the way through third grade. We are also 1% of the way through fourth grade. The reason for that being, as I said before, some topics are repeated from grade to grade. So I do recommend making sure to do that review. Let's zoom in a bit. All right, so where are we at? We finished intro to multiplication. We did a bunch of multiplication and addition and subtraction, some division. We talked about fractions a lot. Okay, so we are in arithmetic patterns and problem solving, and then we're gonna talk about some geometry, it looks like. So let's start with arithmetic patterns and problem solving. Now we've already done some of this. It looks like we're gonna start with math patterns. Now, it's been a few weeks since I've done this show, and I don't actually remember what it means by math patterns, so let's find out. The rule for the pattern shown is add 8. Oh, I see. Math patterns. It is a very early way of describing sequences. A sequence is just a list of numbers. That's all it is. It's just a list of numbers. It doesn't even have to have any rules, although it often does. In this case, the rule is specifically add 8. And because this is third grade, we are giving the student the rule and showing them what to do with it. Whereas when I was a kid, I had to figure out the rule at the same time as I was trying to figure out what this whole missing numbers thing even was. So I do think this is a good way of teaching this. So if we're adding 8 every time, well, we've been adding for a while now. 5 plus 8 is 13, right? 8, 9, 10, 11, 12, 13. Okay, just making sure, use those fingers if you have to. And then 21, 29, 30, 31, 32, 33, 34, 35, 36, 37. No problem. The table below shows the number of laps Sam ran around the track each day. So on day 2, he ran 6 laps. On day 3, 9. On day 4, 12. On day 5, if this is like an actual track, then this kid is, or this person is running a lot of distance. Maybe a cross-country runner or something. If the pattern continues, how many laps will Sam run around the track on day 8? Now, immediately, we are removing one very small, very thin layer of scaffolding. We're not giving them the rule. We're asking them to find the rule themselves. And in this case, the rule is every time the day goes or increases by 1. In fact, let's go ahead and actually write it down. Every time the day increases by 1, the number of laps increases by 3. And it's important to note both sides of this rule, okay? Because sometimes, what if we were talking about, they only ran every other day? Or we want to know how many laps they run every 2 days. Then it might change things, right? So the rule is, every time the day number goes up by 1, the number of laps goes up by 3. So if we were to do that again, for day 6, we would get 18. On day 7, 21. And on day 8, 24. So again, this is learning how to recognize patterns and then extend them. And because this is a very, very young audience still, because the students are still very young at this point, you're going to want to focus on, how do I put this? Focus on the small things. Focus on how the number of days is going up, and focus on how they're adding 3 every time. If you need to, remember how to skip count, and remember to remind them how to skip count, because that's what this is, right? It is skip counting by 3s, 6, 9, 12, 15. So that's another connection that you can make if folks are having a hard time sort of really connecting the dots here. What did I say, 24? Excellent. The table below shows the number of laps Carly ran around the track each day. This is the same exact thing. Oh, but it's asking about what the rule is. So we already talked about this. The rule is add 3. Look at the pattern below. 1, 3, 9, 27. Now this is different. It's pretty clearly not adding the same amount. Let's take a look. In fact, I'm going to zoom in a little bit to make it a little bit easier to see. This is definitely different, because that's plus 2. That's plus 6. So obviously the pattern doesn't involve adding the same thing over and over again. Out of curiosity, what is this? Let's see. 27 minus 10 is 17. That's plus 16. I'm not really seeing any pattern up here. It would have been interesting. I was just wondering if maybe there was a pattern. That doesn't appear to be. But if you look at it a slightly different way, what's happening is we are multiplying by 3 every time. And these are 2 types of sequences, even though we're not giving them a name yet. We're not expecting students to know the vocabulary yet. We are getting people comfortable with the idea that you can. There are a couple of ways that you can increase things. There doesn't have to be a pattern, but 2 patterns that we're going to look at a lot over the course of now through high school and beyond is what happens when you add the same amount over and over and over again. That is called an arithmetic sequence or a linear sequence. And then secondly, what happens if you take a number and multiply it by the same multiplier over and over and over again, by the same ratio. And that is called a geometric sequence or an exponential sequence. And again, at this level, we are not expecting students to know this vocabulary. We're not using this vocabulary. What the point is later on in high school, when we do teach them about arithmetic sequences and geometric sequences, I'm hoping they'll be able to go, oh yeah, we learned that back in 3rd grade, and we reviewed it every single year from then on. And that's kind of the whole point and purpose of this math patterns unit. So the next one, if I was to multiply by 3 again, 27 times 3. 20 times 3 is 60. 7 times 3 is 21. So I think 81 is the correct answer. And let's zoom back out before I... Yes, 81. So again, no worries about knowing this vocabulary. We're just kind of looking at this and saying, hey, what pattern might this be? This was something I actually really enjoyed when I was a student, looking for a pattern and not necessarily yet knowing how to express that pattern. And I really, really like that we are using words. That's really important. We are using words to describe what's going on rather than jumping straight to equations and notation. Because equations and notation have to also be learned. So it's good that we're teaching these patterns before the notation, is my point. So what is happening here? Now, the nice thing with these patterns is you can, if you're given a multiple choice, you can just test, right? They all say start with 4, so that's pretty clear, right? It does start with 4, so check. And then multiply by 4 each time, Well, we can see immediately that that doesn't work because 4 times 4 is 16, not 24, so that one is out. B, start with 4 and multiply by 6 each time. Now that works for the first step, but I know for a fact, without even having to really do the multiplication, that 24 times 6 is going to be more than 100. I'm not going to bother doing the actual arithmetic in my head, but it's not 44 for sure, so it's not B for sure. Start with 4 and add 20 each time. Well, it does look like the tens place is being counted up by 2s, right? 0, 2, 4, 6. I think that's the correct one. If we were adding 10 each time, then we would also have 14 and 34 and 54. I look at finding patterns as almost a game, and I know not everybody likes that kind of game, but it is the kind of game that a lot of video games, especially like mobile games, like Match 3 games, count on. There's a lot of that sort of thought process going on. So what's the next thing? What expression can we use to find the missing number in the pattern? So again, Khan Academy is switching up the wording so that folks understand the ideas and not just the vocabulary. You need to be able to express ideas in multiple different ways. So it looks like to get this number, there are 2 ways I can think of to do it. I could take 60 and then add 15, because it does look like they're adding 15 every time. Or I could take 90 and subtract 15. But I don't think that's what the 3rd grade curriculum has in mind just yet. Although maybe it does, because it does show 45 minus 15 as an incorrect possibility. It is 60 plus 15, and it's not even asking what the answer is, which once again reinforces the fact that answers aren't the point. Getting the right answer is just the result of doing a correct process. The answer is less important than the patterns involved. It looks to me like, oh, it says that the rule is add 15. That's easy enough. 3 plus 15 is 18. And 48 plus 18, 48 plus 20 is 68, minus 2 is 66. I hope I got that right. 49, 50, 51, 52, 53, 63. Yeah, that did not look right. Did not look right. Thank you, Hartman. I appreciate your looking out as well. Anyone can make mistakes, but I'm glad I didn't make that one. Okay.